Good morning to all the juries. I'm Kunal Chauhan and I'll be presenting my research study for my master's. The topic for my research study is music recommendation system using natural language processing and audio feature analysis. The topics covered for this research study are introduction, gap analysis, methodology, evaluation, and then finally the presentation will be concluded by the conclusion. So let's begin. Let's begin with the background of the research study. Since we all are living in the era of Netflix and chill, we all are familiar with the concept of personalization, which is widely taking the globe over. The OTT platforms nowadays, for example, Netflix for that matter, they what the algorithm that they use is that they create a personalized user profile which they make by taking the user personality into account. For example, the user's emotion, and then they have a user history. For example, what the taste and the preferences of the user are in terms of what kind of entertainment does the person like, and they make a personalized user profile which can be accessed at any time and whenever they want. So this made me wonder that why can't we do this with music as well? And that's why I came up with this idea of making a personalized music recommendation recommender system, which also brings us to the research question for this research study. Now, how can a music recommender system be built using natural language processing and audio feature analysis? Since music is much more complex than just plain entertainment, because music is perceived differently with by every human being. Because music is much more complex than just lyrics and audio, and because lyrics are not just word in music, lyrics actually don't just go with the semantics of the words. They actually go with the context by which they are using in the paper uh, in the song. So the focus of this paper is the audio features that we will be focusing on and the lyrics, which makes us wonder about the research objectives, which are the lyric sentiment analysis using natural language processing, in which we'll be doing the sentiment analysis of the song. We'll be figuring out what the kind of mood that the song is setting, and then we'll be moving to the audio feature analysis, in which we'll be extracting the timbre audio features, which include spectral centroid, MFCCs, spectral roll-off, and the 12 octave, which are the chroma frequencies. Combining this, we'll make a recommender system. So let's start. But before starting, we have to actually first analyze the gaps which were there in the previous studies. So the gaps in the previous studies were that there was no research discussed in the report using natural language processing techniques, in which the sentiment analysis was being done, and the audio features were actually being extracted from the scratch without any audio labeling on it. Secondly, uh, all the research studies in earlier times tried to solve the problem of cold start, but what they did was that they were focusing on the pre-existing user history. But here what we have done is that we have got a way around that. We have actually created a pre-existing genre history, which will be used for making the recommendations, and this will be actually used as the classification and the prediction, which will be done by the machine learning and the deep learning models. So let's move on to the methodology. The flow for both the datasets, since we are using two datasets here, that was the biggest constraint of this research study, that no, not a single dataset in which both the lyrics and the audio were available because of the piracy concerns. So that's why we have to use a different dataset for the lyrics as well as for the audio. So the flow for the lyrics dataset is that we'll be performing EDA to achieve a normalized dataset. Then we'll be performing the natural language processing technique by using sentiment analyzer to get the mood of the song. And then we'll be performing the cosine similarities using TF-IDF vectorization, by which we will get the similarity score, and which will actually help in the end to make the recommendations of the songs. Secondly, for the second data set, the flow is that we'll understand the audio and the classify and then classifying the genre. Then the visual representation of the sound waves will be done using Librosa library, which is actually has helped in this model a lot. Then we'll be performing Fourier transform, and then we'll be building the spectrogram, Mel spectrogram for the sonography, and then we'll be doing the feature extraction by extracting the timbre features of the audio. Then we'll be doing the dimensionality reduction and normalization of the data so that we can actually push the data in the machine learning and the deep learning models here, and then we'll be predicting and then classifying the genres to make the predictions. Moving forward, this is the methodology. So tokenization, lemmatization, lexical richness will be done in data cleaning. Then we'll move forward with sentiment analysis, and then cosine similarity, similarity score will be found out, and then recommendations will be done. Similarly, what we'll do is that we'll do the Fourier transform and spectrogram, Mel spectrogram, harmonics, and then timbre feature extraction, then machine learning and deep learning models will be applied, and then we'll be finding out the accuracies of the models that are applied, and then we'll be classifying and predicting the genre of the songs. So let's come to the lyrics dataset. In the exploratory data analysis, tokenization, lemmatization, and we found the new word, unique words, and then we did a check of the length. Then we did some statistics, and for the visualization, as you can see, the total words versus the unique words. Then we did the lexical richness, calculated visualization. Word cloud was done. Post that, NLP was used on for doing the sentiment analysis of the song. So we came up with three broad categories here: negative, positive, and neutral for all the songs. And after that, dominant score was given to the songs for each artist, and then cosine similarity was done using TF-IDF vectorization, and then recommendations were made. Similarly, for the audio data set as well, sample rate found was calculated, Fourier transform was done, spectrogram, Mel spectrogram, and finding after that for feature extraction, we found the zero rate, zero crossing rate, harmonics, and tempo per beat, spectral centroid, MFCCs, etc. Dimensionality reduction was done using PCA, normalization was done using min-max scalar, and then eight machine learning methodologies, and then one deep learning methodology was used. Moving to the evaluation, this was the sentiment analysis that was performed. So you can see for each song, we have a negative, neutral, and positive score that we have found out. And we have taken an average for these three, and then a dominant score was derived for all the songs. So using this, we have actually found out the similarity score. So we have taken Beyonce's first song as the reference, and we have kept the similarity score to 0.25. And based on that, the recommendations are made, which is closest to the first song. This is how the NLP has been done. Moving on to the evaluation of audio dataset. First, the 2D representation of audio signals in time domain has been done. Post that, fast Fourier transform was used because the signals were obviously discrete, and we calculated fast Fourier transform using the hop length and window length, and then the signals were turned from the time domain to the frequency domain. Since the time track was lost, so we didn't know how to keep a track of the time as to when the songs are starting and ending. Therefore, spectrogram and Mel spectrogram were performed, and also now the signals were turned into logarithmic. Post that, the audio feature extraction was done. So the timbre audio features were included. For example, MFCC, as you can see in the diagram, spectral centroid, harmonic, spectral roll off, and the 12 octave of chroma frequencies. All of them were extracted. Post that, eight methodologies of machine learning were actually applied with the augmented dataset, which was actually done by breaking the 30-second audio into 3 seconds each so that we have a larger dataset. And here is the result for all the methodologies. We can clearly see that XGB classifier was the best performing. And then since it was turned into an image dataset, and we know that convolutional neural networks are the best with the image dataset. Therefore, we applied CNN as well, and CNN is actually considered best for classification and prediction, and that's what we got in our results as well. That the accuracy for CNN was 93%. Coming to the conclusion, the main motive of this study was to create a strong recommender system. Even for building this was not just the focus on the semantics. See, for music, it always means context of the words, and obviously, audio features, analyzing audio features is always a difficult task. So, all of that was performed, and based on that, a model was created through which we made a recommender system, which can be also done, which can also be used by other business modules if they are if they want to make better and efficient music recommender system. Because in this recommender system, the problem of cold start using the genre as the main focus is actually solved. So this is actually what we have come up with this research study, uh, and this is where I would like to conclude my report as well. Thank you so much.